Hi all, welcome to my YouTube channel Know About Embedded System. So today in this video I'll explain you how to generate interrupt from SPI protocol. In the previous video we have seen how to generate interrupt from UART, how to generate interrupt from timer, how to generate interrupt from external source and so on. So today we will concentrate how to generate interrupt from the SPI protocol. So if you're a new here to my channel, kindly subscribe my YouTube channel and gain the knowledge on embedded system. So let us start the video. Here you know that SPI is a master and slave based communication. It is able to transmit, master is able to transmit, even slave is able to transmit. That part I have already explained in the previous video. So today, as you know that I'll be concentrating only on generating the interrupt from the SPI. So how the SPI protocol is able to generate the interrupt? At least two scenarios. There are different scenarios out there, but at least here I'm going to tell you two important scenarios. One is whenever SPI master transfer completed, whenever SPI master completes its transmission, or whenever SPI master receives a data. So in both scenarios we are able to generate the interrupt. This is a one scenario, and second scenario is when there is a mode fault error occurs. Interrupt can be generated even in the mode fault. So what is the mode fault? That I'll be explaining in the one more video later. So at least in these three scenarios we are able to generate interrupt from the SPI. Okay, now let us go to the user manual here and we will understand slightly what they're explaining in the datasheet. Then we will go to the coding part. Yeah, this is your register, SPI control register. This in detail I have already explained in the SPI programming video. You can just go and watch. I'll update the link in the description box. Now what we have to understand here is the bit number 7. The register is called SPI control register. In this control register we have to enable one important bit that is called SPI interrupt enable bit. So we have to enable bit number 7 in the register SPI control register. If you enable, in the previous programming we have not enabled this bit, that is called SPI interrupt enable bit. This we have not enabled, but to generate the interrupt this bit should be enabled. So what it says, so bit number 7 says that so a hardware interrupt is generated from SPIF, that means SPI interrupt flag, or a data transmission complete flag it is. So whenever this is set, or whenever the mode fault is set. So in these two scenarios we're able to generate interrupt by enabling bit number 7 of your SPI control register. This is a one important thing we have to understand. And the second important thing is, so SPI status register, here you can see this is there are different scenarios. That is what I told in the previous explanation. SPI is capable of generating more than 4 to 5 different scenarios it can able to generate. So one is abort mode, mode fault, read overrun and write collision. But for demonstration purpose I'm just taking this one, SPI data transmission completion flag. So whenever data transmission completes, SPI master is able to generate an interrupt. Okay, so in this scenario I'm going to generate interrupt. And then next point is where is our interrupt register? Here you can see this is called SPI interrupt status register, or you can say SPI interrupt flag register. Here whenever there is an interrupt, the flag is going to set. Interrupt from the SPI, this particular flag will set. Nothing but interrupt SPI interrupt flag will set. So we have to clear manually. So in the ISR part we have to clear this interrupt flag manually in the ISR. Okay, so this much only the register understanding. So in detail I have already explained the previous video of your SPI programming part. You can just, I'll update the link, you can go and watch there. So coming to the coding part, coding it is similar to our SPI only, but one additional thing is bit number 7. Here you can see line number 59. The line number 59 tells about configuration of your SPI. These things already I have explained in the SPI programming part, bit number 2, bit number 3, bit number 4 and bit number 5. So bit number 2 tells about 16-bit mode. Then we have a uh, C pole and C phase, then we have 16-bit mode. Like this information we have configured, but to enable the interrupt, we have to enable bit number 7. So bit number 7 is interrupt enable, SPI interrupt enable. This is the bit where we have to enable to generate interrupt from the SPI part, bit number 7. This is the one important point we have to understand in the from the configuration. Second point is, as usual, we have to configure from the NVIC side also, NVIC also. So I'm going to enable SPI interrupt from the NVIC as well. NVIC enable IRQ SPI interrupt. I'm going to enable NVIC side, and also I'm setting some priority here, similar to the previous programming. Okay, so enable NVIC and then enable the priority. So this is the one thing, and rest all it is similar to previous programming only. This is my SPI slave configuration by sending some commands, and this is my SPI data transmission, and this is a new thing here. So SPI interrupt handler. So this is a function which is responsible to execute the interrupt service routine for SPI. So here I'm just I'm going to print one string saying that SPI IRQ. Okay, and then here the line number 91, what you're seeing, this is to clear the interrupt. SPI INT. So and then here you can see the comment what I have written, clear the interrupt flag. So that means whenever there is a SPI interrupt, it will controller will come here and it will print SPI IRQ, then clear the interrupt. Only two important things. One is a SPI handler inclusion, and then enabling NVIC side, and then enabling the interrupt from the SPI side. Only this much additional information compared to SPI main programming. So coming to the main programming here, as usual, clock configuration, UART configuration, SPI configuration, SPI slave configuration. Yes. So now what I'm doing here is, this is my main code, and this is my SPI data transmission. Okay. So every time, first I will print UART, then I will transmit one SPI data. So once you transmit SPI data, we're able to generate an interrupt. So first UART will print, and then SPI will transmit data, and as soon as SPI completes its transmission data, we're able to generate an interrupt. Okay, so now let us see that, and I'll just remove the breakpointer here. Go to debug window. I will show you output in the simulation window only. Okay, so this is my SPI, this is my UART section. Just you observe what is going to happen now. I'll just enable. Yeah. So now what is happening? Try to understand here. I have enabled SPI interrupt enable. This one, what you are seeing, this is SPI interrupt enable, and here you can see the since I'm transmitting SPI data continuously, for every data transmission, the SPI interrupt is setting, and we are clearing in the interrupt service routine. Right? You can see here. So I'll just show you in another way. So before, I'll put one breakpointer. Yeah, so we will put one. Yeah, here I'll put one breakpointer. So let us run it. Yeah. Now you can see what is happening. So what is happening currently? I have kept one breakpointer here. So in the breakpointer, I'm able to print one UART string followed by one SPI data transmission, and as soon as SPI data transmission is done, interrupt service routine will execute. That is nothing but this one, SPI IRQ. So again I'll give the run here. So one One is one normal, nothing but main program, and then followed by SPI IRQ. And observe here in the interrupt section. So what is going to happen? If you observe here, this bit will set and then it will be clear. Now you can see. So you might have observed here. Observe very carefully. The interrupt bit will set and it will be get cleared. Okay, so in this way, so we can generate interrupt from SPI as well, and we can go to ISR and we can do some action. Okay, so now I have allowed to run continuously and observe SPI interrupt is setting and then cleared by the interrupt service routine. And alternatively, the normal and SPI request is printing. That is because of main code and from the ISR routine. Okay, so in this way you can generate interrupt from the SPI. So I hope this video is clear. So if you feel this video is an informative video, click on like button and subscribe to my YouTube channel.